Hello everyone, this is my presentation on my genetic disorder that I picked for class, and I picked the biotinidase deficiency. Biotinidase is an autosomal recessively inherited disorder, and it occurs when the vitamin biotin is not recycled correctly within the body. Biotinidase provides instructions, or BTD provides instructions to make biotinidase, which is the enzyme that recycles biotin in the body. And biotin can be found in milk, egg yolks, and liver. It's a B vitamin, so some people can get the supplement of that through the foods, but if they have biotinidase deficiency, it's not enough in order to correct the disorder. Biotin is removed in the body by biotinidase, which leaves the vitamin in its unbound state in the body. It's needed in order for biotin-dependent carboxylases to break down fats, proteins, and carbohydrates in the body, and this is the reasoning behind why biotinidase deficiency is considered a form of multiple carboxylase deficiencies, because it causes the impairment of several enzymes within the body that produce biotin. When BTD is mutated, the activity of biotinidase is reduced or completely eliminated from the body, and in profound biotinidase deficiency, this activity is reduced to less than 10% of normal, and this can cause a lot more symptoms and require a little bit more treatment than partial biotinidase deficiency, when the activity is only reduced to about 10 to 30%. Biotin can't be recycled properly without enough of the enzyme, and this causes a lack of free biotin within the body. And then the bio-independent carboxylases become impaired, which causes a buildup of compounds in the body that can become toxic and create the symptoms. And these signs or symptoms are due to the damage of cells and tissues from the buildup of the compounds that have been left in the body. The treatment for it is pretty simple. You just have to have supplemental biotin in the free form, which you can't, like I said, you can't always get from food, so you have to have a supplement of it. It just has to be regulated in order to make sure that there's not too much or too little being produced in the body. The symptoms of biotinidase deficiency can be mild or more severe. In partial biotinidase deficiency, most of the symptoms only occur when the person is stressed, or they're sick, or there's an infection in the body. They're similar to profound biotinidase deficiency, and they include hypotonia, skin rashes, and hair loss, like alopecia. If left untreated, children can exhibit ketolactic acidosis, organic acidemia, and mild hyperammonemia. In adults, the symptoms can be optic neuropathy and or peripheral neuropathy, and they're often misdiagnosed instead with multiple sclerosis, since they weren't diagnosed as a child. If these symptoms progress too far, they can become permanent, and the treatment can possibly alleviate the symptoms, but it won't stop them from occurring. In profound biotinidase, the more severe symptoms can cause seizures, hypotonia, which is weak muscle tone, so they can kind of lose the ability to perform tasks just because they don't have the strength to do so. They can have breathing problems, hearing and vision loss, ataxia, which comes from that hypotonia, so they have movement and balance problems, alopecia, which is just hair loss, and they can get fungal infections. If children are affected and it's not treated, it can delay them developmentally. Over here I just have a picture of the rash that can occur from it, and going back to here, we can see some kids that are affected by this. So this is where the alopecia is occurring, and after treatment, and then they have like a little bit of a rash on their hands, but after treatment has been given, they do grow their hair back, and the rash does seem to be alleviated by the treatment. One downside of the treatment is that it does have to be continued for their whole life. They can't stop it, otherwise the symptoms will come back or become permanent. There's no serious side effects for biotin therapy that they've found. The prognosis is good as long as the treatment is started before the symptoms start occurring more frequently, because after the symptoms have started, like I said, they may be irreversible. The testing can be done in a normal newborn screening or genetic counseling if you think that the symptoms your child is showing pertain to biotinidase deficiency. Prenatal testing is not as necessary because the disorder is highly treatable and it is pretty rare as well. Like I said, it's a rare disorder, Profound biotinidase deficiency begins during neonatal period, and partial biotinidase begins around 3 months of age after birth. Males and females are both equally affected. In profound biotinidase, 1 in 140,000 people are affected. Partial biotinidase, 1 in 110,000, or 1 in 60,000. And about 1 in every 120 people can be carriers of one gene of biotinidase. And the gene that's responsible for this mutation is just simply called the BTD gene, and it's located on the chromosome 3q25, and this just shows a cycle of biotin, and just all the compounds that work together to create like a normal biotin cycle in the body. And then over here is when you have that biotinidase deficiency, where that X is, where it has been cut out. So the biotin is not being produced properly, and that leads to the deficiency in the disorder. Like I mentioned previously, it's an autosomal recessive pattern, and it's caused by mutations on the BTD gene. Since it is a recessively inherited gene, that means that both parents can be carriers, but won't necessarily show symptoms of it, and both parents have to carry the gene in order to pass it on to their offspring. This is a pedigree that I actually created that shows how the biotinidase deficiency can be inherited through different generations, and since it's rare, I didn't have too many people that were affected with it. It can affect both males and females. So the ones with the dots are carriers of it, and the ones that have the red square are ones that are actually affected. So we just have a couple throughout the pedigree, throughout a couple generations, that are affected by it. For genetic testing, there are actually 133 different types of testing that are available to the public. There's 2 different biochemical genetics tests, an analyte and an enzyme assay. And then the molecular genetics test, there's a lot more options for that. You can do a mutation scanning of the entire coding region that is affected, deletion or duplication analysis, sequence analysis of select enzymes, or a sequence analysis of the entire region, or you can do a target variant analysis. And these are offered through pretty much anything that offers genetic testing. Now with that, it might not show specifically if you're going to get the disease, or even if you're a carrier, there might not be a chance that you'll produce it within your offspring. And since it's a rare recessive disorder, it's not mandatory. It can be done during newborn screening. If there's a positive reaction that suggests there might be a biotinidase deficiency, further diagnostic testing will be required later on to determine whether or not it was a positive or a false positive. It's normally done, like I said, during newborn screening, and a small blood sample is taken to determine the range that they have of the biotinidase deficiency. And if it's out of range, they'll do a test later on to confirm whether the result was active, or just because the blood sample was too small and it didn't count enough of the deficiency in there. Early detection is important because it shows up around the newborn stage to 3 months, but it can show up in adolescence as well. And like I said earlier, if the symptoms progress too far, they will become irreversible, and this is the vision problems, hearing loss, the developmental delay. Those who have profound biotinidase in younger children or adolescents, they can have motor limb weakness, spastic paresis, and decreased visual acuity. And this is why early screening is important, because if you catch it early enough, it's easy to treat. It costs about $200 for a walk-in test, but insurance normally covers most newborn screenings. 23andMe, LabCorp, a bunch of companies in like Germany offer this testing, but you can get it at pretty much any facility. And there's not really any controversy that surrounds this. It's just a simple blood test that's done during newborn screening or in early childhood if symptoms begin to appear then. And these are the references that I used just to find more information on this. Thank you.